Welcome to the prisoner's dilemma. Let's get started. The prisoner's dilemma is best explained with an example. Let's say Home Depot and Lowe's are each deciding how much wood they should sell. If both decide to sell 50 wood, they would both profit $120. If one decides to sell 50 wood and the other 100 wood, the 50 wood seller would receive $50 and the 100 wood seller would receive $150. If they both decide to sell 100 wood, they would both receive $80. We can organize these different scenarios using a payoff matrix as shown here. The row represents an amount of wood which Lowe's wants to sell. The columns represent an amount of wood which Home Depot wants to sell. The bottom left triangle in each section tells how much money Lowe's receives for each situation. The top right triangle shows how much money the Home Depot receives. To determine how much wood each company will sell, we need to think in the perspective of one of these companies. Let's say we're Home Depot. If we think that Lowe's is going to sell 100, then we should also sell 100. This is because if we sell 50, we would gain $50, and if we sell 100, we would gain $80. Since $80 is bigger than $50, this would be a better outcome. What if instead we consider that Lowe's was going to sell 50? In this case, we would still want to sell 100. This is because if we sell 50, we would gain $120, and if we sell 100, we would gain $150. Since 150 is bigger than 120, we would again conclude that we should sell 100. The key point to recognize is that no matter what Lowe's does, we should sell 100. This makes selling 100 the dominant strategy. The dominant strategy is defined as the best strategy regardless of the opponent's strategy. If we thought from the perspective of Lowe's, we would still come to the conclusion that selling 100 is the dominant strategy because Lowe's has the same outcomes as the Home Depot. Now that we know the best strategies for both parties, what will happen when they use them? Using their dominant strategies, they sell 100 and each gain $80. This is what's called the Nash equilibrium. The Nash equilibrium is defined as the point where both parties won't change their strategy because they aren't incentivized to after considering their opponent's strategy. In this instance, neither party will change their dominant strategy because changing to sell 50 would lead to worse outcomes. However, we can see that if they instead both sell 50, they would both gain $120. Since $120 is greater than $80, we can see they didn't maximize their profits. Now this is because the Nash equilibrium does not lead to the optimal outcome. Interestingly, even though they used their dominant strategy, it resulted in worse outcomes for both. This is the dilemma of the prisoner's dilemma. Obtaining the optimal outcome is difficult because it requires both parties to trust each other. One way this can occur is through repetition. In the Home Depot and Lowe's case, if one side chose to sell 50 and betray the other, that betrayal would be remembered in future transactions. This would prevent mutually beneficial transactions and reduce profits in the long term. The threat of revenge ensures cooperation and profit for both. In this video, we talked about the prisoner's dilemma. Thanks for watching.